Okay, so one of the last things I want to talk about is not necessarily any more visual components that you can play with, but it's a way to start to structure your graphical user interfaces and the data that represent them. And the idea is used not just within Java, but it's used in a lot of graphical user interface places, and it's known as the model view controller idea. So this model view controller, it's been around for a while, so developed at Xerox PARC in 1978. And the idea is that it separates the graphical user interface and the program around it into three separate components. So we have the view, which is what we see, right? It's what we see. We can click on it, we can do things with it. But we have two other components. We have the model and the controller. So this is the model view controller architecture. And so the view is what we see. The controller deals with user input, and the model is where the application data is stored. So you might have Facebook data or YouTube data or Twitter data model where we can store that in a list and we can manipulate it, we can sort it, we can index it, we can do all sorts of things with it. And we don't care what the view is, we just want to be able to manipulate that model. And we might view it through the command line. We might view it through a user interface with a graphical user interface on a desktop, might be on a web page, could be on a mobile device, but that data model might stay the same. So we get a bit of a separation from this, and it makes more robust graphical user interfaces. We get a lot more reusability from our code we write, both the model and the view code gets a lot of reuse out of it. So there's a sort of interaction order that happens under MVC. So the person will interact somehow. They type on their keyboard or touch their screen or click their mouse. So they perform some action. Then it says here that the controller may request changes to the model. So update yourself, put some new numbers in, sort, do something to it. The controller may tell the view to update in some way. You've been clicked, so make yourself look like a clicked button. The model may notify the view it's been modified in some way. So it'll come up through here and manipulate itself. And 5, the view may need to query the model for current data in some way, so it knows something's changing. So quick, tell me what's happening. And 6, the view updates the display for the user. So there's a separation through here, how we control it, what the model data is, and how it's viewed. And as I said, this gives us so much more reuse. So imagine if we had to have a different text field for every different type of a boolean, a float, all the different classes had to have a different text field. That just wouldn't work, right? So the text field is abstract of those. It just deals with text, and those data items have to be able to produce the text for it. So we have a separation between them. So advantages, right? Makes it more robust, easier to maintain. I just deal with my GUI and I say, well, this is the interface that's going to make to drive it, and I just maintain that. I don't have to maintain it for every single piece of data that could exist out there, just what I say it's going to do. And then on the other side, the model, we just produce the model in the way we want, conform to some specification, and we can manipulate that model. And the model can be used not only for command line, it could be used for different graphical user interfaces, and the same graphical user interface could be used across different models through there. So it makes it more robust and easier to maintain and more usable. So the model here contains the application and its data, provides methods to access and update the data. So we need to have that interface. How do I get some data out? How do I get a string out of it? So, we've got like a toString in all the objects. Yeah. How do we update that data? So we have some sort of interface to define those interactions. So we have some sort of fixed interface for the model and the GUI to be able to pull and push information from them. So the view, so this is the visual representation. This is the button. You can click the text field with the little characters written in it, right? They're not actual real characters. They're just different dots on the computer screen, but it's the visual representation that gives it that. So multiple views can be displayed at the same time. So you could have the same data being represented as a table and as a graph at the same time. And that's fine. It's the same data. You don't need to replicate the data. The two views use the same data model. All right, and that's really cool. So when the model is updated, it'll propagate that information out through maybe some eventing architecture to update it. And this should be automatic. So if I update the model, that table and that graph will automatically update as well. And the controller deals with the interaction with the user. So it captures the mouse movements, the keystrokes, the touches, the different parts of it, and communicates that activity to the model and indirectly updates the view. Right, now just to really drill this home, there is a model view controller song. So let me just sing that for you. No, I'm not going to sing it, but we will get the person who wrote it to sing it for us. So strap yourself in for some tunes.
So I guess it was just a little while ago, and I had the good fortune to see this technology before it was rolled out here at WWDC. And as sometimes happens with technologies that I get stoked about, the first thing I do is go to the iTunes Music Store and type in some keywords, see if there are any songs about it. And there weren't any.
So there were no songs about model view controllers. There you go, hey?
Not one song about model view controller. So then, of course, the next step is I tend to write one. So this year's song is a model view controller song. And once again, I thank you for your kind indulgence. Are we good to go? Am I good to go? And we're going to switch over to demo machine, the one Victor's in front of. One or two. All right. And it goes something like this. Model view, model view, model view controller. MVC is a paradigm for factoring your code into functional segments so your brain does not explode. To achieve reusability, you gotta keep those boundaries clean. Model on the one side, view on the other, the controllers in between. Model view, it's got 3 layers like Oreos do. Model view, creamy controller. Model objects represent your applications raised on Detra. Custom classes that contain data, logic, and etc. You create custom classes in your app's problem domain. Then you can choose to reuse them with other views, but the model objects stay the same. You can model a throttle in a manifold, model of a 2-year-old, model a bottle of fine Chardonnay, model all the glottal stops people say, model the coddle in a boil in eggs, model the waddle in Hexley's legs. 1, 2, 3, 4. Model view. You can model all the models that pose for GQ. Model view controller.
So hopefully you're getting the point there that you can model whatever you want. You can model all sorts of different things. And what we'll see is through song is that we can model all these different things and they can all be used in different sorts of views.
View objects tend to be controls that view and edit. Coco's got a lot of those, well written to its credit. Take an NS text view, hand it any old Unicode string. The user interacts with it, it can hold most anything. But the view don't know about the model. That string could be a phone number or the works of Aristotle. Keep the coupling loose.
So the whole point in here is that our view that we have could be anything. It's a view of text, that's what it shows, but the data that's feeding it from the model, it doesn't know what it is. It doesn't care what it is. It's just data, and it can display it as text. So this data needs to be able to turn itself into text. And if it can be displayed. And the view, we don't need to write a view for all different types of models or data. They just have to be able to produce it. And that's one of the key goals with this model view controller idea through here. So I think that's mostly everything we need to know.
Intimately, they often are hard coding, which is very foreboding for reusability. But now you can connect any value you select to any view property. And I think you'll stop binding, then you'll be finding less code in your source tree. Yeah, I know I was astounded. That's not even a rhyme.
Yes, I'll let you, in your own time, watch the whole song. So, model view controller, so important that someone wrote a song about it, and like I said, it's used in lots of different GUI designs. So it's one of these core principles of GUI design. So the model should perform the actual work and should be independent of the graphical user interface. So it wants to be loading the data, manipulating the data, being able to do different things with it is all about the model. Right? So the view should not be sorting, it should not be searching, should not be indexing. That's part of the model part of it. There has to be a little bit of connection, but not the view. The controller lets the user control what the program is doing. Go do a sort now, go do a search now. The design of the controller depends on the model, and the view lets the user see what's happening. But the key thing is it should not display what the controller thinks is happening. It should display it based on what the model is. So the model's separate, never mix model code with GUI code. The view should represent the model as it really is, not some remembered status. And so it needs to have a connection, so some sort of eventing connection maybe, where as the model changes, it notifies the view that something has changed in there. So in GUIs, user code for the view and controller tend to mingle, especially with smaller programs. A lot of the view is in system code. So you can ask yourself then, have I intermingled it too much? You can ask, could you reuse your model if you want to port the application to a command line textual interface, right? Maybe that's what you've done in the past, is written a command line. Could you take that and use the model in a graphical user interface? Could you create it for an interface for the blind? Could you take your model and put it into an Android mobile device? So you might have been writing Java. Could you take your model and put it in Android, which is like Java? Could it be plugged into a web application, run on a web server, a Tomcat Java web server? So if you could do that, and you don't need to take too much out of the graphical user interface code, then you've probably got a good model. So Swing is not Apple. So it has a slightly different view on what the model view controller is. So the model view controller Swing model combines the view and the controller into a single element, which it calls the UI delegate. So the model maintains the information, the state of the data, and the UI delegate draws and reacts to the events, right? So usually we click on the visual element. So that's the operation, that's what the controller deals with. And the view state of that is tied up within that graphical element. So we usually have the model, and we'll have the view and controller bundled up together as this UI delegate idea through here. So each Swing component usually has two unique objects. It has the model, handles the state information about that component, and the UI delegate. And the state information might be very simple. Is it checked? Is it not? or it might be very complex. What's the list information contained within it? And the UI delegate determines how it paints itself based on that model's state info. So we call this a separable model architecture because the view and controller are tied up together, but the model is separate. And that's the key thing, keeping that model separate. So the models provided by Swing, we have GUI state models and application data models that they have. So GUI state models are about defining the visual status of the GUI controlled, right? Is the button pressed? Is an item checked or unchecked? Is a radio button selected or not? And it says here, typically relevant only in the context of the graphical user interface. And we have things like a button model, a list selection model, which one's selected, a tree selection model, which one in the tree is selected. Application data models are the more interesting ones, and they deal with the data that's providing the visual representation of the graphical user interface. So some sort of quantifiable data. So it might be a list of data, and we want to represent that somehow. Items in a list, cells in a table, how we want to do that. So it's different from the GUI data, and it has a very clear separation between that application data logic and the GUI. So a few examples of those are the JTree, JTable, and JList. And we'll look more at this list model architecture. So the list model, you could just initialize it with an array or a vector, and then it's just all bundled up within the JList, and we don't have access to it all anymore. But a more powerful, more flexible way is to use a list model to deal with that. So here's an example. So there's a default list model, which does all the implementation because list model itself is an interface. So there's the default list model. We can create it, and we can create our JList, which is a visual list with items in it. And then we need to connect the view, which is the list, to the model. And we can do it with saying equals JList model, or we can actually say list.set model as well will work. And then when we come to populate that model with data, we don't add it to the list, we add it to the model. And then the JList, because it's connected, will be notified and it will update itself as it should through there. And when we remove things, we don't remove it from the list, we remove it from the model. And then the model will fire an update to the list, and it will update itself through there. So the JList is automatically updated. So when we're dealing with the data, we just manipulate the model, not the actual visual representation of it. So we have a separation between the view and the model. We can do all sorts of interesting things. So we can define our own new abstract list model here, and the get size could be the max value of short, so some big number, and the get element is the current index that you are at in here. And so this will give you a very long list that you can scroll through. So we can define all sorts of list models here.